given the polynomial function f of x equals negative x cubed plus 16, and we're asked to find the x-intercepts, which could also be referred to as the real zeros or real roots of the polynomial function, and then asked to find the f of x-intercept, which could also be referred to as the y-intercept. So when we have an equation given in function notation as we see here, if it's helpful, we can replace f of x with y, so we could rewrite this as y equals negative x cubed plus 16. These two equations would be equivalent. So now to find the x-intercepts, or again the real zeros, of any function, we set y equal to 0 and solve for x. So if we're using function notation here, we'd substitute 0 for f of x, or using y, we substitute 0 for y and solve for x. So in either case, to find the x-intercepts, we want to set up and solve the equation 0 equals negative x cubed plus 16. Let's isolate the variable term by adding x cubed to both sides of the equation. So now we'd have x cubed equals, this would be 0, so x cubed equals 16. And now to solve for x, to undo the cubing, we'll now cube root both sides of the equation. The cube root of x cubed would just be x. So we have x equals the cube root of 16. But this will simplify. If we look at the prime factorization of 16, 16 is equal to 4 times 4, and 4 is equal to 2 times 2. So 16 is equal to 2 times 2 times 2 times 2. Notice how 16 does have a perfect cube factor, since here we have 3 factors of 2. So this will simplify. The cube root of 2 cubed would just be 2, so we have 2 times the cube root of 2, which would be the exact value of the x-intercept. We're asked to give the x-intercept as an ordered pair, so the x-coordinate would be 2 times the cube root of 2, and the y-coordinate would be 0. We should also mention that because this is a degree 3 polynomial, and there's only one real zero or one x-intercept, that means the other two zeros would be complex, which we'll address in another video. And now to find the y-intercept or f of x-intercept, we set x equal to 0 and solve for y or solve for f of x. Let's go ahead and use the equation here with y in it. So to find the y-intercept, we're going to set x equal to 0 and solve for y, which would just give us y equals, this would be negative 0 cubed plus 16. So we can easily see that the y-intercept is going to be 16. So the coordinates of the y-intercept would be the point 0, 16. Now let's go ahead and verify our x-intercept and our y-intercept, or f of x-intercept, using the graphing calculator. To verify the x-intercept, though, we will have to convert 2 times the cube root of 2 to a decimal approximation. Let's go ahead and do this from the home screen. So we're going to press 2, and then math, and then option 4 for cube root, and then 2, close parenthesis, enter. So the x-intercept will be approximately 2.52. Now let's press y equals, enter the function. So we have negative x raised to the third power plus 16. Now from here, if we press zoom 6 for the standard window, we will see the x-intercept, but we won't see the y-intercept because for the standard window, the y maximum is only 10. So from here, let's press the window key. Let's go ahead and change these slightly. Let's change the x min and x max to negative 5 to positive 5. And then for the y minimum, let's go from negative 5 to the y max of, let's say, 20. So we'll press graph. So there's the y-intercept and there's the x-intercept. Let's go ahead and calculate the x-intercept to make sure that it's approximately 2.52. We can tell, though, it does look like it's going to be approximately 2.5. So we're going to press second trace for calculation. We're going to select option 2 for the 0 to find the x-intercept. For the left bound, we're going to move the cursor closer to the x-axis, but we want to stay to the left, which in this case means we want to stay above it. So I went way too far. Let's go back. Maybe somewhere in here. Enter. To the right, in this case, would be below the x-intercept. Maybe here. Press enter. Enter again. Notice how this does verify that our x-intercept is correct. It's approximately 2.52. And now to check the y-intercept, we're going to use the table of values. So to set up the table, let's press second window. Start the table at 0. Enter. Then changing the table, let's change this to ones. So the table will start at 0 and then change by ones. And now if we press second graph, very quickly notice that when x is 0, y is 16, verifying our y-intercept. I hope you found this helpful.